closed last night, but the quiz is still open all the way till next Wednesday. But guys, it keeps happening that when I open stuff in AP Classroom and I give you guys these due dates, I give you guys time in class to work on stuff, that people are still just not doing it, okay? That is on you. You've got to figure out the time. I mean, we've had a lot of work days lately, and we have another one coming up on Friday. So like I said, if you want to work on the quiz on Friday in class, great. You're more than welcome to. But if you choose not to, or you're absent, planned or unplanned, figure out when you are going to do it. It's your responsibility. Don't wait till the last minute. Do it, okay? So Friday's a work day. Work on the quiz if you want to. There'll be a homework check at the end like every work day, so just be ready for that. You already know one of the assignments that I'm going to be checking, because I check it every time that I assign it. Think about it. And even though, so the quiz that is open is 2.8 and 2.9. We finished 2.9 yesterday. The two of you that were absent yesterday, make sure you just catch up so you're not behind. And even though we're moving on, I told you that everything we learned yesterday is going to be used in the subsequent sections, and you'll see that today. So there's a little bit of what we did yesterday in today's lesson, and it's just going to keep going. So I would say make sure that you're really comfortable with section 2.9 so that moving forward you are good. Okay, so the inverse of an exponential function is a log function. And I'm going to prove that to you a few ways today. But remember what inverse means. Let's not forget these things. You guys know, like, you take American history, world history, let's take American history. You learn about the Civil War, right? And then you have a test on the Civil War. And then you move on to World War I. You don't have to know what happened in the Civil War necessarily to understand the new stuff. You guys know in math, everything builds on the stuff we've done before. That's why you don't even want to blink in this class because you miss something that's going to be important. So remember, inverse, here it is again, that was from section 2.8, means switch x and y. Don't forget that. Switch x and y, whether it's domain and range, whether it's an ordered pair, a table of values, in a in an equation, right? If you have x and y, you switch x and y, and then you still have to solve for y. But that's what inverse means, okay? And I'm going to show you that here in a second. So right here, example 1 is we're using the exponential function y equals 2 to the x. We're going to graph that. So that's going back to like the first half of this unit where we were graphing and doing all kinds of stuff with exponential functions. And then I'm going to show you what the inverse is and how we just can switch the x's and y's, and we'll talk about all that, okay? But let's just start with good old-fashioned... Oh, sorry, guys. I mean to interrupt your conversation. Weston and Ethan, I didn't mean to interrupt your conversation. Sorry, I just thought it was rude of me. I'm so sorry. So, guys, remember, you do not have to do any graphing on a test or AP exam. So anytime we're going to do some graphing in here, we're going to make it really simple. Don't stress about it too much. But they built us a nice little XY chart here to graph the exponential function. So let's just use that. So remember, anything to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4. And then you just flip these numbers, right? So you're just putting 2 to the negative 1 in the denominator. Sorry, that's a 1/1/2. Put this in the denominator, that'd be 1/4, okay? And so we're going to graph that very sketch, okay? Look, they didn't even give us grid marks, all right? So we're just going to do a nice quick sketch of this. Left -2, up a teeny tiny bit, a little bit more. There's that y-intercept, right? 0, 1, 1, 2, and 2, 4. And remember, it's really important that you guys are understanding the behaviors of graphs. We should be able to talk about asymptotes and concavity and intercepts, domain, range, end behavior. And one of the things we've talked about is as these points get closer and closer and smaller, you can figure out where your asymptote is, okay? So this graph right here has a horizontal asymptote at y equals what? What would it be? 0, yeah. So why is that important? Well, it helps us finish the graph, right? We know we're not going to cross down into there. We're just approaching y equals 0 at that place, right? Okay. And remember, guys, when you name an asymptote, you can't just say 0 or -3 or 5. That was a mistake on the last test. One of the FRQs questions was 2 points. What's the asymptote? And you had to write y equals -3. And some of you just wrote -3. So don't forget, you have to state which type it is. All right, so what I'm going to show you right now is just that, well, let me just show you, tell you like this. These two are inverses. We're being told that. I will prove it to you in a minute, okay? But if they are inverses, I can just flip the x and y's and graph those, right? So my x's will become my y's, and my y's will become my x's, right? So now we're going to graph this one. So let's see what a graph of a log looks like. To the right a teeny tiny bit, down 2. To the right a little bit more, down 1. We have an x-intercept at 1, 0, 2, 1, and 4, 2. So just kind of estimating where those points are. And again, by the behavior of this graph, we're getting really, really, really close to this vertical line, and that is going to be the asymptote of the log function. And we should be able to tell that by that. So in this graph, we have a vertical asymptote at x equals 0. Not 0, x equals 0. So remember, hey and vax, horizontals are always y, verticals are always x. Hey, vax. Okay? Now, something I pointed out a few days ago, we talked about for a quick second in the notes, I told you that if you graph a function and its inverse, it will always be symmetric over that line of y equals x. Okay, so we graphed all three, but that's just, and here's my last year's one, looks a little bit nicer. And it's not perfect, right, because we're not sketching it perfectly, but if we graphed all these points really nicely, like on a graphing calculator, if I folded my paper right there on y equals x, all the points would match up, okay? So we're always symmetric on that line, all right? Now, let me just show you algebraically how these two are inverses of each other, and this is going to be a little bit of a review of yesterday. So if I take, let's start with the log function, log base 2 of x, right? That's what that says right there, right? That's a y. And if I find the inverse of it, I would switch x and y. But don't forget, with an equation, you have to still solve for y. How do you solve a log equation? You write it in its other form. So in other words, to bust up this log equation, I need to get y by itself. So to be able to separate that, I write it in its other form. And this is that skill, one of the 2 skills from yesterday that I said you guys really have to know how to do. You're going to do it like 7 trillion times in this class. And remember, it's that loop-de-loop thing we do. We start with the base, wherever it is. Remember yesterday, a lot of the times, all the time, it's on the left-hand side. Who cares? Here's my base. Power to the other side equals that. And you don't have to show the loops, okay? It's just a method to help you remember. So that's 2 to the power of x equals y. So there you go. They are inverses of each other. You can see it algebraically. You can see it graphically over that line. You flip the points. Just big concept that we have to know. Okay? So even though we don't have to do like official graphing in this class, just some sketches, of course, here and there. We do have to be able to dissect them. And I mean, from day 1 in this class or day 5 or whenever we really got into this stuff, we have been talking about these things. I mean, how many times have we talked about concavity and end behavior and all that stuff? So what we're going to do is dissect this log graph a little bit more and a little bit more accurately so we can answer these questions. We already made an XY chart for it, okay? So just take these points, take a second, and graph them a little nicer on this gridded graph, okay? So everybody take a second and just do that. Remember, it's hard to graph little fractions. Do the best you can. Good. Now let's answer some questions. What is the domain of this graph? Like, this isn't memorization. It's not like, oh, now we're in logs, so every time I get the range and every time I get, it's going to be this. We don't want to think like that in this class because we should be getting better and better, or maybe even we're already there, of just looking at a graph, just any random graph. Who cares what it is? And being able to answer lots of questions about it. Like, looking at this graph, is my domain all real numbers? No. Because look, something is stopping me from going left and right. Remember, domain is my x's. I can go to the right forever, right? There's no wall blocking us. But to the left, I am blocked. My graph wanted to go that way, but it got stopped, okay? So the domain would be from 0 to infinity, right? 0's as far as we go. Would we put parentheses or a bracket on our 0? Yes. Parentheses. Remember, you'll always use parentheses at an asymptote because that's the definition of it, right? It's not part of the graph. How about the range? The range is the y values. Is there anything stopping us from going up forever and down forever? Nope. So, all real numbers, also known as negative to positive infinity, right? Here's our end behavior. Already started for us. Remember, we want to know how to write end behavior limit statements perfectly for the AP exam. Okay, the limit of f of x as x approaches infinity. So as x goes to the right, what are our y values approaching? Positive infinity. Good, right? It's going up forever. Now look at this limit statement here. It's changed a little bit. It doesn't say the limit of f of x as x approaches negative infinity. He can't go to negative infinity. We just talked about y, right? He's being stopped. He can't go there. What is he approaching? It is approaching 0. Do you remember what that little plus sign means? From the right. Yeah, from the right, if that helps you to write it there. And if you see a negative there, it means from the left. So as this graph approaches 0 from the right, where are the y values going? Negative infinity, right? They go down forever. Okay, so the little change in our limit statement. We have an asymptote at something equals 0, right? And remember, vertical lines are always x. If it helps, I think I've given you this trick before. The word vertical starts with a V, and the top half of an x is a V. Helps me remember. Vertical line, x equals 0. Okay. We have an intercept at 1, 0. Remember, intercept could be x and or y, where the graph touches either the x and or the y axis. And what do we say? Concave up or down? Concave down. It doesn't ask for it, but we could say this is an increasing function, right? It's rising left to right. My AROC between any 2 points would be positive, things like that. Okay. All right, let's go to the next page. So, we're going to do another one and answer some questions about it. So we weren't given a fun little XY chart. Let's use our graphing calculator and use the table of values to graph this one. So you guys want to go to y equals. And you want to type that in. Remember we learned yesterday how to type in a log with a base? It's math, alpha, math. Just hit those buttons real fast. They're right on top of each other. Math, alpha, math. The more you do it in class, the more you're going to remember it on the test. And you can put it in as a fraction, or you could use 0.5, and then x. I mean, that's simple, right? You can graph it if you want to. Okay, it's going to look something like that. Fine. But to graph it properly, we're going to use the table of values. So go to your table, and these are all the points. Now, there's a lot of decimals in here. Ignore them. Pick some nice points. Pick some friendly points. For example, 1, 0. I like that one. 2, -1. That's easy to graph. 4, -2. How many points do you have to make? That's up to you until you can see the shape. Now, you might notice that it says starting at 0, And if I keep going up, those are all errors because there's no points over there, right? We have an asymptote at 0. So it should make sense to you that those are all errors. So that's a way of seeing where your asymptote is on your graphing calculator. So now I can just finish this because I know as my graph gets closer to this pink line, the asymptote, they're just going to get smaller. Okay, so easy, quick way to make a graph. You don't have to make this too crazy. Okay, the domain sure is not all real numbers. Again, we're from 0 to infinity, right? But the range goes up forever and down forever, so real numbers. So notice when your b value is a fraction, how the graph changed to when, so let me say it differently, to when your b value is greater than 1, like 2, it is an increasing function. See how it rises left, right? And when your b value is less than 1, it's a decreasing function. That's what changed there. But we can answer this easily. As the graph goes to the right, the y values are actually going down, right? Going down. And as x approaches 0 from the right, our y values are going towards positive infinity. Vertical line at 0. Intercept 1, 0. And of course, concave up. Okay? We have one last example. Example 6, if you want to scoot over to it. Now listen, you have one homework problem just like this. One short homework, okay? The only one that has any kind of work to it is the one like this, okay? So this is going to be like number, I think it's 7 in your homework. So you definitely want to make sure you know how to do this. Okay, so what we're going to do is all this stuff. We're going to graph this function. Then we're going to graph its inverse. I'm going out of order, just like we did on the first example. And then I'm going to show you how to find its inverse algebraically, switch x and y, solve for y, and then analyze means answer some questions about it. I'm going to kind of change the order around. Okay, so first thing we're going to do is graph f of x. Again, you use your calculator, okay? So everyone should be typing this, not just watching me. I know how to do this. I'm doing it for you. And there is something to be said about muscle memory, okay? So practice typing this in. Because notice, there's some things going on in this equation. There's a vertical stretch by factor of 2. And then what is a plus 1 in parentheses? What do you think that's going to do to all of our points? What direction would the plus 1 in parentheses move? That's going to move us left 1, okay? You're going to let your calculator handle all that for you, but tomorrow we'll be looking at equations and having to say all those things again. All those, there's a vertical stretch, there's a flip over the x-axis. The same thing I've taught you 500 times, and so a bunch of other teachers. So tomorrow should be pretty simple, I think. Okay, so let's type this in. 2, math, alpha, math, base 2, and then of course, x plus 1. You can see what the graph is going to end up looking like, but we're going to go to our table of values and pick some nice points. Okay? So I'm going to scroll up. I want to see where my asymptote is. I see that it's at -1. That should make sense. It was at 0 on the parent function on the 2 graphs we graphed before, and then we shifted all the points left 1. Well, that's going to shift your asymptote as well. So you will have an asymptote at x equals -1. Sometimes it just makes it easier to have the asymptote in there first. It's up to you. And then pick some nice points. Okay, so now I have a point at 0, 0, and 1, 2, and 3, 4. You want more? You can keep going. 7, 6. The more points you have, the nicer your graph is, but that's good enough, right? I can totally see the shape of this graph. Okay? We graphed it. Let's analyze f of x. Let's just quickly go through these things that we know. Domain is not all real numbers, and it's not 0 to infinity. We shifted to the left, so now look at your graph. It's -1 to infinity. Range, all of them. As x goes to the right, what are my y values doing? They're going up. And that's a mistake right there. Remember, that log function cannot go to negative infinity. It is approaching what's it approaching? -1 from the right. That's what we're doing. We're approaching -1 from the right, and the y values are getting smaller, right? We have an asymptote. It's a vertical line at -1. Don't just write -1. That's wrong. Intercept. Your origin can be an intercept, guys. That is the x and the y axis, right? And concave down, right? Okay. So now we're going to graph this guy's inverse. We don't need to do a whole bunch of fancy stuff, guys. Inverse means switch the points. Switch everything. Switch everything. Anything that's an x becomes a y, anything that's a y becomes an x. So we're going to do that with points, but let's also do it with the asymptote. If you have an asymptote at x equals -1, on the inverse, it would be at what? Y equals -1. So I know I'm going to have a horizontal line at y equals -1. And then just take some points off of here and flip them. You already have the table values, just flip them. 0, 0 can't flip. It's going to be right here, right? How about 2, 1? So instead of 1, 2, I can pick 2, 1. Instead of 3, 4, I can do 4, 3. Instead of 7, 6, I can do 6, 7. I didn't even plan that. I didn't. You guys are so over it. Everyone's like, oh, yeah. Okay, that's good enough, right? We know that what's going to happen as it gets close to the asymptote, it's going to look like that. All right, great, perfect. Just one little side note, even though it didn't talk about it, don't forget, if you graph a function and its inverse, you'll have that line of symmetry that goes right through y equals x. And if I do say so myself, my graph looks pretty good. It does look very symmetrical. Okay, so anyway, we graphed that. Let's analyze it. Okay, so now you're looking at the J-looking graph. Remember, that's all real numbers, which should make sense because the domain of this guy is the range of this guy. Same thing here. The range of my inverse is the domain of the function, right? From -1 to infinity. Everything switches if it's called x or y in an inverse. Okay, so the limit of f of x as x goes to the right, of course, as we go to the right on the J-looking graph, we are going up. And as we go to the left, just like it says here, I'm not going to rewrite it, as we go towards negative infinity, right, the J graph, my purple one, goes to the left forever, we are approaching what? -1. Right? We can't get any further down than -1. Intercept still 0, 0, and we are concave up. Okay? All right, so we analyzed, we did all the graphing. Let me show you, and this is something I did not show you yesterday, is when we do, I'll show you what I mean. So to do this algebraically, I'm going to just use this blank space up here. Okay? So guys, what you have right now is y equals 2 log base 2 of x plus 1. We're going to find the inverse. Algebraically means manually showing your work, okay? So switch x and y. So I have x equals 2 log base 2 of y plus 1, right? So I switched x and y, solve for y. Okay, so remember, y is trapped in this log, so I have to unravel this, right? And this is one thing that we didn't see yesterday. So before you can write a log in its other form, because that's what we're going to be doing, the little loop-de-loop, you have to do some cleanup sometimes. Before you can do 2 to the power over here, the log has to be by itself. And what I mean by that is the word log, its base, and its argument. Okay, see how it's all in parentheses? All of that is called the argument. So this 2 out in front, we need to get rid of it. Just using algebra, divide both sides by 2. So you'll have x over 2 equals log base 2 of y plus 1. Okay? What other cleanup could you see? There could be like a number off to the right of here. That's what moves your graph up or down. Like if there was a plus 3 over here, you would subtract 3 from both sides. But you have to get to this point, which is where we were always started yesterday, where the log, base, and argument are by itself. Now you can 2 to the power of whatever's on the other side equals the argument. So 2 to the power of x over 2 equals y plus 1. Anything else to do? Subtract 1, Zoe, because it says solve. We know switch x and y, solve for y. So we have to get y by itself. You don't have to show subtract 1 from both sides. I know you guys know that you subtract 1 from both sides. Okay? So the inverse would be 2 to the power of x over 2 minus 1. That's it. All right. Page something. I don't know. Where's my page? It's missing. 121, does that sound right, guys? It's... Oh, I did. I threw it away. Sorry. Yeah, 121. Is that what you guys said? Okay, I'm going to do 3, 4, 5 with you. That'll leave 6, 7, and 10. Okay. Ready? All right, number 3, it says find the inverse. Okay? Find the inverse. So you hear inverse, you go, okay, switch x and y, solve for y. So let's see, is there any cleanup? Nope, I have log, its base, its argument. I can go right into 3 to the x equals y. And if I didn't say it already, you do not have to show those little arrows, okay? And if you look at my key, she changed y to like y. You don't have to do that, but I just wanted you to understand because it wasn't named f of x. It wasn't like f to the negative 1x. So whatever, this is fine, okay? All right, same thing here. I'm going to switch x and y. And again, there's no cleanup because of the parentheses here, guys. That's saying the whole thing is the argument. If there were no parentheses, I would have to subtract 2 first, okay? So start with your base. Remember, this is called a common log. What is the base of a common log? 10. We know there's a 10 there. We're typically never going to see it there. We just know that's 10 to the x equals y plus 2. Y is not by itself. I need to subtract 2. Right? Easy peasy. Number 5 is the one I really wanted to get to with you. Nope. No, I'm going to switch x and y. Okay, definitely do this with me because there's a very easy mistake that could be made in here. Okay, so you switch x and y. There's no cleanup, right? We have log, its base, its argument already by itself. So we do our loop. Now we have to get y by itself, right? So opposite of multiplication is division. Now here is the thing I want you to be very careful of. 2 to the x over 2 does not equal 1 to the x. Okay? I could see us making that mistake. I have seen people make that mistake. Why isn't it? Well, we don't know what x is. What if it was 2 to the negative 11 or something over 2? It wouldn't equal 1, okay? We don't know what that is, so we can't assume that that's 2 to the first power. This is the answer if and only, well, even then it wouldn't be, anyway, it says it's not right. So how do we simplify this? Because it's not simplified. We want 1 base. So remember, that's a 1, right? If you had to give that denominator an exponent, it would be 1. And what do you do when you have like bases with division? What do you do to your exponents? Subtract. Good. So that's 2 to the x minus 1. Okay? That's an easy place to make a mistake. I mean, it makes sense when you see it, right? But so you have 6, 7, and 10 to do. I'll put the up.